Hi everyone, this video is going to go over how to draw orbital diagrams for different elements. We're going to talk about the symbols for an orbital diagram, go over the rules, there are 3 of them. We're going to look at some examples, do those together, and then give you a chance to try some on your own. So grab a piece of paper and follow along. Let's start with orbital diagram symbols. So there are a few symbols that you need to know. First up, you might see a box like this, or you might see just a line drawn like that. These are orbitals. So the reason they're called orbital diagrams is because we're going to be drawing these different orbitals for the electrons to go in. So the box or the line like that, that's considered to be an orbital. If you see an arrow pointing up or down, that is going to be an electron. You'll notice that only 2 arrows or electrons can fit in each box or orbital. So you can have 2 arrows per box, which is really saying 2 electrons per orbital. So you should never have more than 2 arrows inside a box or on a line. Whenever we are drawing these, you're going to notice that there's only 1 box for S. There will be 3 boxes for P, 5 for D, and 7 for F. And remember, when we say boxes, we're really talking about orbitals. And they're going to be drawn like this. So for the S, you'll only have 1 box or line. For the P, you'll have 3. Very close together, or you'll see 3 lines like this close together. And then same thing for the D and F. The reason that there's only 1 for S is because if you notice in your electron configuration, the maximum that we can count across in the S block is 2, like 1s2, 2s2. That's the highest we can go. And if 2 electrons can fit in each orbital, well then 2 divided by 2 is just 1. So we only need 1 orbital. And then for the P, if we kept going with this configuration we had, we know that the highest that can fit in the P sublevel would be 6. That's how many elements we can count across. So divided by 2 electrons per orbital, and now we get, divided by 2, we get 3. So that's where the 3 comes from. So for the D, you notice that on the periodic table, the most you can count across would be 10. 10 elements in the D block divided by 2 electrons per orbital, 5. F, 14 divided by 2 would be 7. So those are just a few things that you need to know. Up next, we're going to talk about 3 rules that really govern how electron configuration turns into an orbital diagram. And the first one is the off-bow principle, and you use the off-bow principle all the time when you're writing electron configuration, but you didn't know it was called the off-bow principle. So all the off-bow principle means is that we build up our electron configuration. We go in a particular order, and when you go in that certain order of electron configuration, you are actually going from lowest energy to highest energy. So electrons will always occupy lowest energy levels first. Something that's correct would be you go from 1s2, 2s2, 2p, let's say 3. That is correct. Something like 2s2, 1s2, 2p3, that is not correct. So whenever you go in order for electron configuration, you are using off-bow's principle to build up. For the Pauli exclusion principle, you're going to notice that when we start drawing these pictures, those boxes, those orbitals, they can have a maximum of 2 electrons, but only if the electrons are pointing opposite directions. For example, if we were drawing some orbitals, this is acceptable because our electrons are going in opposite directions. This would be unacceptable. Our electrons are going in the same direction here, And that's not okay. Our electrons have to go in opposite directions. What that's representing when the electrons go in opposite directions, that's representing the spin of electrons. So electrons spin clockwise or counterclockwise, and we're representing that with arrows. So Pauli exclusion principle says you can have a maximum of 2 electrons, 2 arrows, per orbital, per box, so maximum of 2 arrows in one box, only if they have opposite spins. So that's the Pauli exclusion principle. The next rule is Hund's rule, which I personally like to call the Beyonce rule. More on that in just a second. But here's how Hund's rule works. Let's say we were looking at an electron configuration, and the electron configuration was turned into an orbital diagram. And let's just say that this was 2s, that was 2p. What the correct thing to do is you fill in each orbital with a single electron before it can pair up. So this one, there was only 1 orbital. For this, we have 3. So you go in order. You go 1, 2, 3, all with a single electron before you start pairing up your electrons like that. So single electrons first. That is correct. What is incorrect to do would be something like this. This is incorrect because we should have 1 arrow going up in each of these 3 before we start going down. So that would be incorrect there. So the reason I like to call this one the Beyonce rule is because it's all the single electrons. So single electrons first across a sublevel before you start pairing the electrons up. So a single electron per orbital before additional electron with an opposite spin can join it. So all the single electrons first before you start pairing them up. Now that you guys know the symbols and you know the rules, let's start looking at how this works. So we're going to go through 2 examples together, and then you're going to try it on your own. So our first example is nitrogen. The very first step is that we need to write out the electron configuration of nitrogen. So before we can make an orbital diagram, we need to know where the electrons are. So take a second, pause the video, write out the electron configuration for nitrogen. All right, for nitrogen, you should have 1s2, 2s2, 2p3. That's step 1. Step 2, we are going to draw corresponding orbitals. So we're going to use some of the symbols that we talked about and the rules. So every s orbital only has 1 box. P orbitals have 3, D has 5, F has 7. So let's take this one section at a time. Our first part is 1s2. So to draw 1s2, it's an S, it's going to get 1 line, 1 orbital. You can draw a line or you can draw a box, either's fine. I end up just drawing lines because boxes take longer, and then by the end of the orbital diagram, my boxes look horrendous. So I just typically draw a line. We're going to label it as 1s. So we drew 1 line because it's an S. And now this number up here, that stands for the number of electrons. So we're going to draw our electrons. So step 3 is draw electrons according to rules. And these rules are the ones we talked about before: Aufbau, Pauli, and Hund. We've got an arrow going up and an arrow going down. So 2 arrows for 2 electrons. And we are done with the first part. The next thing we're going to draw is 2s2. Because it's an S, it only gets 1 line. Let's leave some space here between these 2. You don't have to add a comma or anything, but we'll leave some space. Let's label it as 2s, and then we have 2 electrons, 1 going up, 1 going down. Our next part is 2p3. So you remember from the symbols that a p sublevel has 3 orbitals. So we're going to go 1, 2, 3, and this is 2p. Sometimes you might see them labeled as x, y, and z, and that's fine, but you don't have to do that. And then we have 3 electrons. Now, to put them in according to the rules, we need to go like this: 1, 2, 3. Because per Hund's rule, every single orbital needs to have a single electron before it can double up. And that finishes the orbital diagram. So this part, this is an orbital diagram. So all an orbital diagram really is just a pictorial representation of electron configuration. What we're doing is we're showing specifically within these orbitals how many electrons there are and what their spins look like. So with nitrogen, we could be really specific and say, you know, in this first 2p orbital that would technically be on the x-axis, there's only one electron and it's spinning this direction. So it just gives us a way to be really specific about those electrons. The next one we're going to try is iron. We remember our first step from up here is to write out the electron configuration. So take a second and write out the electron configuration for iron. Go ahead and pause the video. Okay, let's check out your electron configuration. Your electron configuration should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Step 2, we need to draw these corresponding orbitals. So here's how this works. Anytime we see an S, we're drawing one line. Anytime we see a P, we're drawing 3 lines. And now if we see a D, we're going to draw 5. So 5 lines, 5 boxes. Let's start. Let's go from left to right. Build up according to Aufbau's principle. Make sure you have some space. This is going to be a rather large orbital diagram. First section is 1s2. It's an S. We draw one line. It's 1s, 2 electrons, 1, 2. This part is now done. Next is 2s2. We'll leave some space. S gets one line, one orbital. 2s, 2 electrons, 1 goes up, 1 goes down. Finishes this part. Next is 2p. P gets 3 lines, 1, 2, 3. We'll label it as 2p. We have 6 electrons, 1, 2, 3, and then 4, 5, 6. Make sure you go in that particular order. That's one of the rules. Next is 3s. It's an S. It only has 1. We've got 2 electrons, 1, 2. That part is done. Now we have 3p. It's P. We've got 3 orbitals here. And we have 6 electrons. So we go 1, 2, 3, all up. Now we match 4, 5, 6. We're almost there. And then we have 4s, 2. That part is done. And last one is 3d. So when we get to the D, we're going to draw 5 lines. 1, 2, 3, 4, 5 lines. We label it as 3d. And we input in 6 electrons. 1, 2, 3, 4, 5. And now that full sublevel, each of those orbitals have 1 electron. Now we match up and we put 6. And that is the orbital diagram for iron. By the way, you might see these diagrams drawn upwards. So if you see something like this instead, where it goes 1s, and then you see 2s, and you might see 2p off to the side, that is fine as well. What that's doing is showing you increasing energy. So energy increases as you go up, as you know, through energy levels. A lot of times I don't draw them up this direction just because it takes up a lot of space. One is not correct over the other. This one just shows increasing energy this way. However, if we read across, we have increasing energy this way. This way is just a bit more friendly in terms of like writing it on a piece of paper. But if you ever see that, now you know. Okay, your turn to try 2 of these. Picked out 2 of them, so give them a try. First one is chlorine, Cl. Second one is arsenic. So pause the video, then write the electron configuration, draw the orbital diagrams, and if you get stuck in a certain point, ask questions, and then go over the answers. All right, give it a go. All right, let's go over chlorine first. So here's your electron configuration for chlorine. If we write it down, we know that all of our S's have 1 orbital. That could be drawn as a box, or you could just draw it as a line. So you've got 1 S, 2 electrons, 1, 2 takes care of that. Next is 2s. We've got one line because it's an S, and 2s2. Now we have 2p6. 1, 2, 3, 4, 5, 6 for 2p6. Then we have 3s2. And our last part is 3p5. So we go up 1, up 2, up 3, down 4, down 5. And that takes care of chlorine's orbital diagram. Next we have arsenic, a little bit larger, pretty significantly. So let's go through this. So you've got 1s2. Then you've got 2s2. Then you have 2p6. 1, 2, 3, 4, 5, 6. Next is 3s2. 3p6. Next, we've got 4s2. We're going to drop it down here because we ran out of space. If you still have space, you're welcome to continue on. For 3d, D has 5. And there's 10. So we've got 1, 2, 3, 4, 5, down 6, 7, 8, 9, and 10. And the very last piece is 4p3. So 1, 2, 3 lines because it's p. We'll label it as 4p, and we've got 1, 2, 3. It should look like that. All right, and that was your last practice. One more time just to show you in case you see, or when you see an orbital diagram written like this, just know that as we go up, it's showing increasing energy, but it's the same thing as written out to the side. Keep in mind that 1s then is at the lowest energy, and then whatever's at the top will have the highest energy. But keep in mind too, like 2s versus 2p. 2p does have slightly more energy than 2s, just a little bit as well. For our recap, you guys are able to look at the symbols, rules, and you did some examples. So the symbols, these boxes or lines, those are called orbitals. The arrows are electrons. You know that a maximum of 2 electrons fit in each orbital. And you know how many orbitals to draw for each block, S, P, D, and F, 1, 3, 5, and 7 respectively. There are 3 rules for writing out orbital diagrams. The first one, off bow, we always go in order. Poly, we always have our arrows going opposite directions. And then Hund, we put electrons in single before we double them up. And then you guys worked through some examples. If you have questions, let me know. If you would like to go back and rewatch the video, you absolutely can. That is it for drawing orbital diagrams.